Hello students, welcome to my YouTube channel. Today we will learn what is relations. So this topic is basically for standard 11 ISC and Cbse as well. So basically this is the overview of the chapter. We will first discuss the ordered pair, then we will discuss the Cartesian products, and then we come to the definition of relations, and then we will discuss the inverse of a relation. So first we will learn what is called an ordered pair. Now an ordered pair consists of two elements in a given fixed order. Suppose if we say A comma B, where A is the first element, and B is the second element. So this is an example of an ordered pair where the order of the elements are fixed. So the definition is an ordered pair consists of two elements in a given fixed order. For example, if A and B are two sets, then by an ordered pair of elements we mean a pair of the form A comma B in that order where the first element belongs to the first set A and the second element B belongs to the second set B. That is, A comma B belongs to A cross B. Next, in the ordered pair A comma B, A is called the first component and B is called the second component. You can call this A as first component or first element and this B as second component. The ordering of the two elements in an ordered pair is important. You cannot write A comma B as B comma A because it will entirely change the meaning of this. Next, the two elements of the ordered pair AB need not be distinct, means B can be equal to A. Like we can have the ordered pairs like AA and BB. Next, equality of ordered pairs. Two ordered pairs A1 B1 and A2 B2 are equal if and only if the first component of the first ordered pair equals to the second component of the second ordered pair. Means first component of first ordered pair must be equal to the first component of the second ordered pair. Similarly, second component of the first ordered pair must be equal to the second component of the second ordered pair. Right? Next, we come to the definition of. First, let us give an example of this. Suppose we take a point in the xy plane where this is the x-axis and this is the y-axis. Similarly, this is the x dash and this is the y dash. Here we take 2 points. Suppose we take the point 1 comma 2, 1 units on the x-axis and 2 units on the y-axis gives us this point 1 comma 2. Similarly, if we take another point, say 2 comma 1, so 2 units on the x-axis and 1 unit on the y-axis gives us this point. Clearly these 2 points lie on the xy plane in the first quadrant, but they are not equal. This point lies over here and this point lies over here. Therefore, in general, a comma b is not equal to b comma a unless a equals to b. If a equals to b, suppose for the point of 1 1, if you interchange the position, means first goes to this place, then also we can say that these two are equal. Similarly, if we consider 3 comma 2, so 3 units on the x-axis and 2 units on the y-axis. 3 comma 2 point is this, and if we take a point 2 comma 3, 2 units on the x-axis and 3 units on the y-axis, this point is 2 comma 3. We can see that 2 comma 3 point is over here and 3 comma 2 point is over here. So 2 comma 3 point is not equals to 3 comma 2. This is basically the conclusion. Generally AB is not equal to BA unless A equals to B. We have shown the example also. Next, one question for you, that find the value of x and y if x plus 3 comma 5 equals to 6 comma 2x plus 5. So we equate the first component of the ordered pair to the first component of the second ordered pair. We get x plus 3, we get x plus 3 equals to 6, and from here we get x equals to 3. Similarly, if we equate the second component of first ordered pair with the second component of second ordered pair, we get 5 equals to 2x plus y. This equation we get, and we already know the value of x, so putting the value of x over here, we can get 2 into 3 plus y equals to 5. Now 3 2s are 6 plus y equals to 5, which further implies that y equals to 5 minus 6 equals to minus 1. Similarly, you may try this question 2. This question is also based on the equality of ordered pair. So given 2 ordered pairs, you need to find the values of a and b. So to find the values of a and b, we equate first with first and second with second. So we have found out the value of a and b as 2 and 1. You can try this question yourself. Next topic is the Cartesian product of two sets. Now, what do we mean by the Cartesian product of two sets? So, let A and B be two non-empty sets. The set of all ordered pairs of the form AB such that A belongs to the first set A and B belongs to the second set, capital B, is called the Cartesian product of the two sets A and B and is denoted by A cross B. That is, A cross B will be of the form, A cross B contains all those ordered pairs AB where the first element comes from the first set and the second element comes from the second set. Here, if we say that A comma B belongs to A cross B, this can happen if and only if A is in first set A and B is in second set capital B. If and only if. This is the sign for if and only if. Now we have said here non-empty set. So if suppose if A equals to empty or B equals to empty, then A cross B will be equal to phi, as there will be no element in A as well as in B. Next, let us see how to calculate A cross B and B cross A. So given a set A equals to 2, 4, 6 and B equals to 1, 2, we need to find A cross B and B cross A. Now for A cross B, we will take those ordered pairs of the form AB such that this A is from set A and this B is from set B. Therefore A is from set A, means 2, 1 will be here, then 2, 2, 4, 1, 4, 2, 6, 1, 6, 2. Similarly, you can see the arrow diagram where 2 goes to 1, 2 goes to 2, 4 goes to 1, 4 goes to 2, and 6 goes to 1, 6 goes to 2. Similarly, if you want to find the Cartesian product of B cross A, we define this as B comma A. Why B comma A? Because here B is the first set, here B is the first set and A is the second set. Now we will consider all those pairs of the form B comma A where B belongs to the first set B and A belongs to the second set A. Here B will be called as the first component and A will be called as the second component. Now B cross A will be equal to B is 1, so the ordered pair will start from 1, then it will map with the elements of A. So B cross A will be 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6. I hope this is clear to you. Let us take another question. If A contains 2 elements, say A and B contains 3 elements, 1, 2 and 3, we need to find the value of A cross B and B cross A cross A and B cross B. Now by the definition of a Cartesian product of 2 sets, A cross B will contain all those pairs of x, y such that x belongs to the first set A and y belongs to the second set B. Now this A maps with the elements of B. So first pair will be A, 1, then A, 2, A, 3, B, 1, B, 2 and B, 3. Similarly, if we want to find the value of B cross A, then here this will be of the form y, x such that y belongs to the B and x belong to set A. So B cross A will be equal to, the first element will be from set B, so this will be, and this maps with the elements of A, so this will be 1, A, 1, B, 2, A, 2, B, 3, A, 3 comma B. Fine. See this. B cross A equals to 1 comma A, 1 comma B, 2 comma A, 2 comma B, 3 comma A and 3 comma B. We have shown this by an arrow diagram where the elements of B maps with elements of A under this R. 1 goes to A, 1 goes to B, 2 goes to A, 2 goes to B, 3 goes to A, 3 goes to B. I hope the Cartesian product of two sets is clear to you. Next, A cross A. Now, how to solve this A cross A? Means A cross A means set A to set A to set A. Means in place of B we have set A only. So set A is this. Set A is basically contains two elements. So A goes to A goes to B. So A comma B, B goes to A, B comma A, B goes to B, B comma B. Now let us see for three sets, Cartesian product of three sets. Let A, B and C be three non-empty sets. Then A cross B cross C is of the form A comma B comma C, such that this A belongs to the first set. This A belongs to the first set A. This B, this B belongs to the set B, and this C belongs to set C, right? For example, let A equals to 1 comma 2, B equals to 3 comma 4 and C equals to 4 comma 5. We need to find A cross B cross C. So for that we will first find A cross B. Now A cross B will be of the form of the ordered pair A comma B, such that A is from first set and B is from second set. So the first element will be 1, 3, second element will be 1, 4, third 2, 3, 2, 4. If you want to see the arrow diagram, it will be like this for A cross B. This is your set A, this is your set B. Set A contains two elements, 1, 2. Set B contains two elements, 3, 4. So now the mapping will be 1 goes to 3, 1 goes to 4, 1 comma 3, 1 comma 4. Now 2 goes to 3, 2 comma 3, and 2 goes to 4, 2 comma 4. I hope this is clear to all of you. Next, but we need to find the value of A cross B cross C. This is equal to A cross B cross C. Now we have find out the set A cross B. This set multiplied by 4 cross 5, 4, 5, 6, right? So this set will be of the form A cross B cross C equals to, consider this as the first element. First element maps with first element of this, first element maps with second element of this, and first element maps with third element of this. So after the mapping we get 1, 3, 4, 1, 3 with 4, 1, 3 with 5 as 1, 3, 5, 1, 3 with 6 as 1, 3, 6. Next we have the element 1 4 maps with 4 gives us 1 4 4. 1 4 maps with 5 gives us 1 4 5. 1 4 maps with 6 gives us 1 4 6. Similarly, for 2 3, 2 3 maps with 4 to give 2 3 4. 2 3 maps with 5 to give 2 3 5. 2 3 maps with 6 to give 2 3 and 6. Similarly, for 2 4, 2 4 maps with all of this and we get the required Cartesian product. I hope the Cartesian product of 3 sets is clear to all of you. Next topic is, this question is for you. If A contains 2 elements, say 1 and 2, you need to find the value of A cross A. So how we will find this A cross A cross A? Means this is the Cartesian product of 3 sets, right? This is the Cartesian product of 3 sets. And those 3 sets are A itself. So first of all we will find A cross A and then we will find A cross A cross A. Now A cross A will contain all those ordered pair of the form AB such that this first element belongs to set A and this second element belongs to set A only. So A comma B belongs to set A only. Now A cross A you can find out easily, as A is this set. So 1 goes to 1, 1 comma 1, 1 goes to 2, 1 comma 2, 2 goes to 1, 2 comma 1, 2 goes to 2, 2 comma 2. This is set A to set A, right? Next we want to find A cross A cross A. This will be equal to A cross A cross A. So basically this set is A cross A. This will map with this set as shown earlier. 1 comma 1 maps with this element 1 to give 1 1 and 1. Similarly 1 comma 1 maps with 2 to give 1 1 2. 1 comma 2 maps with 1 to give 1 2 1. 1 comma 2 maps with 2 to gives 1 2 2. Similarly 2 comma 1 maps with 1 to give 2 1 1. Similarly 2 comma 1 maps with 2 to give 2 1 2. Similarly 2 comma 2. Similarly this 2 comma 2 maps with 1 to give 2 comma 2 comma 1, and this 2 comma 2 maps with 2 to give 2 comma 2 comma 2. I hope this Cartesian product of 3 sets is clear to all of you. If you have any doubt, you can comment in the comment section. Next, again we need to find the value of A cross B. So given A is this, B is this, you can find out easily. Now how to find A cross B? A cross B will consists of all those pairs such that A is in first set A and B is in second set B, right? So 1 maps to X, you can see by this arrow diagram. 1 goes to X, 1 comma X, 1 goes to Y, 1 comma Y, 3 goes to X, 3 comma X, 3 goes to Y, 3 comma Y, 5 goes to X, 5 comma X, 5 goes to Y, 5 comma Y. So basically this is the ordered pair which we want to show. I hope this arrow diagram is also clear to you. Now see, number of elements in the Cartesian product of two sets. If A and B are two non-empty sets such that the cardinality of A is M and cardinality of B is N, then cardinality of A cross B is equal to cardinality of A multiplied by cardinality of B. For example, consider this set A and B which contains 3 elements 1, 2, 3. So the cardinality of A here, cardinality of A is 3 and the cardinality of B is 2. Now we know how to find A cross B, Cartesian product of two sets, by this. So we have find out the Cartesian product of two sets A cross B. Now you count the number of elements in A cross B. 1, 2, 3, 4, 5, 6. So cardinality of A cross B is 6. So here cardinality of A is 3, cardinality of B is 2 and cardinality of A cross B is 6. Now cardinality of A cross B means the number of elements in A cross B, which is equal to 6 equals to 3 into 2, which is equal to cardinality of A into cardinality of B. Remember this as a formula, that cardinality of A cross B is equal to cardinality of A times cardinality of B. I hope this is also clear. Similarly, number of elements in Cartesian product of three sets. So let A, B and C be any non-empty sets such that cardinality of A is P, cardinality of B is Q and cardinality of C is R. Then cardinality of A cross B cross C equals to cardinality of A, which is P, multiplied by cardinality of B, which is Q, multiplied by cardinality of C, which is R. So the cardinality of A cross B cross C equals to PQR. That's it for today's class. On next class we will discuss this relations, right?